Hello! So, we're at the penultimate question in the paper. Now, traditionally in maths papers, the harder questions or the more involved questions are found towards the end of the paper. Okay, because up to now you've probably been given questions where you're only asked to do you're only asked to practice one area or two areas of maths, okay? But here you're going to start putting stuff together and you're going to have to be using lots of different areas of maths at once, okay? So it's fine though, just work through it logically, okay? Like I'm going to show you how to, and you'll be fine. So, John has an empty box. And obviously the logical thing when you've got an empty box is to fill it with red counters and blue counters. Now, we've been told that the ratio of the number of red counters in the box to the number of blue counters is 1 to 4. So, another ratio question. They really want you to understand what ratios mean, okay? So what does this ratio mean? It means that for every one red counter, I must have 4 blue counters. So in actual fact, I'm going to draw up a little table, okay? So I'm going to draw up a column with the number of red counters that I've got. I'm going to draw a column with the number of blue counters that I've got. And then my final column is just how many counters I've got in total. Okay, so put some lines in like that. So let's just take the ratio at face value. Let's suppose I have 1 red counter. Well, how many blue counters will I have? I must have 4 blue counters, which means that I'll have how many counters in total? I'll have 1 red counter, 4 blue counters, so I'll have 5 counters in total. Okay. Now let's suppose I have 2 red counters. Well, what does this ratio actually mean? It means that for every one red counter, I'll have 4 blue counters. Alright, so if I've got 2 red counters, that must mean I've got 4 times as many blue counters, so I've got 8 blue counters. So how many counters do I have in total? I've got 2 red, 8 blue, so I'll have 10 counters in total. Okay, what happens if I have 3 red counters? Well, I've got to have 4 times as many blue counters as red, so I've got to have then 4 times 3, which is 12. Okay, so how many counters do I have in total? I'll just have 15. Okay, do one more. Let's suppose I have 4 red counters. Well, then how many blue counters will I have? Well, I have 4 times as many, so I'll have 16. Right? And how many counters do I have in total? I'll have 4 plus 16, which is 20. So can I come up with a generalisation then? Let's suppose I have, let's suppose I have X red counters. I could call it anything, but let's just suppose I have X. It's just a number which can take multiple values. It's a variable. Okay, so let's suppose I have X red counters. Well, then how many blue counters will I have? Well, this ratio tells me that for every one red counter, I'm going to have 4 blue counters, which means I'll have 4 times as many blue counters as red counters. Which means that I must have, if I've got X red counters, I must have 4 X blue counters. So then if I've got X red counters and 4X blue counters, how many counters do I have in total? Well, it's a bit like saying if I've got 1 xylophone and I add another 4 xylophones to it, how many xylophones do I have in total? I have 5 xylophones, or 5X. Okay. So now we've got that in our head, and this is useful, by the way. Now we can read the rest of the question. So Linda takes 2 counters at random from John's box. So if she takes 2 counters at random from John's box, well, there's only 2 options. She can either have a red counter or a blue counter. So let's actually draw out what she can have. So let's suppose she starts here, okay, and then she can either take a red counter or she can take a blue counter, which means that if she starts here, she can either go down this direction and take a red counter or this direction and take a blue counter. Okay, then if she sits here, so let's say, for example, she takes a red counter first, then she puts her hand back in. We assume that she hasn't put that other red counter back in, so she doesn't replace the counters each time. Then, unless it says so, then if she's got 1 red counter in her hand, then she puts her hand back in, takes out another counter, well then she can either have a red or a blue counter on her second pick, alright? But what if she'd taken a blue counter on her first pick? Well, then she can either take a red or a blue counter again. Yeah, there's no kind of limitations. You can either take a red counter or a blue counter again. So the question is, what are the probabilities on these branches? So what is the probability of her taking a red counter? Well, are you happy that probability is just given by, so the probability is just given by your event that you're interested in, so event you're interested in, out of the total number of events that you could have, so total number of events. Right? So if she takes, so let's just look at this branch again. So she's taken a red counter on her first go. So if she takes a red counter, well, what is our formula for a red counter? It's just X, right? X is just a red counter. So let's say, for example, she's taken a red counter on the first go. So that means she's taken X as her event. She's taken X as the counter, all right? And how many counters has she got in total? Well, she's got 5X in total. She's got 5X counters in total to choose from. So she's chosen a red counter, but she could have chosen any one of the 5X counters. So this is what this branch is saying, okay? Similarly with the blue branch, well, how many blue counters are there? There are 4X blue counters. So there are 4X blue counters. How many counters are there in total? There are 5X counters in total. There's 5X red and blue counters. So 5X red and blue counters in total. Okay, let's look at this branch here. Well, this branch, how do we get to this branch? We had to travel along this branch here first. So it means that she's taken a red counter on her first go. It means she's taken a red counter on her first go. Okay, so then what's the probability of her getting a red counter on her second go? Well, the thing is, she's already taken a red counter out. So she's going to have one less red counter to choose from, right? So she's taken one red counter out, so it means she has one less red counter to choose from. So she's not got X, she's got X minus 1. And how many counters in total does she have? Well, you're happy, she's no longer got 5X counters in total, because she's already taken a counter out. So she's got 5X minus 1, she's got one less, okay? So now let's look at this branch here. Let's look at this branch here. So let's say, how do we get to that branch? Well, we had to travel along this red branch first. So she took a red counter on her first go, and then she's taking a blue counter. Okay, so she took a red counter on her first go. Okay, but then, how many blue counters she got left? She took a red counter on her first go. How many blue counters she got left? Well, she's still got 4X. She hasn't taken any out. She's still got 4X blue counters left. How many counters she got in total? Well, she did take a counter out on her first go. So she's no longer got 5X, but she's got 5X minus 1. All right. So then let's look at the next branch. So let's look at this one down here. Sorry, just draw that one back in. So then let's look at this branch down here. Well, how did she get to that branch? She had to take a blue counter on her first go. So if she took a blue counter on her first go, what's the probability of getting a red on her second go? Well, she got a red on her second go, then, well, how many red counters she got? Well, she hasn't taken a red counter out, so she's still got X. Okay, how many counters she got in total? Well, she did take a blue counter out on her first go. So therefore, she's no longer got 5X counters in total. She's got 5X minus 1. 5X minus 1. Okay, let's look at the last branch then. So let's look at this branch down here. So how do we get to this branch? Well, she had to take a blue counter out on her first go. So if she took a blue counter out on her first go, what's the probability of taking a blue counter out on her second go? Well, how many blue counters she got left? She's not got 4X anymore. She's got 4X minus 1. She's got one less because she's already taken one out, okay? And how many counters she got in total? Well, she did take a counter. She took a blue counter out on her first go. She's not got 5X left anymore. She's got 5X minus 1. Okay, so these are all the probabilities on the branches. So the question says then, the probability that she takes two red counters is 6 over 155, so 6 over 155. So if you took two red counters, then that means that she must have taken a red counter on her first go. So it's this branch here. It's not this branch down here because that's a blue counter on her first go. She must have taken a red counter on her first go and then a red counter on her second go, right? Because she's only taken two counters. So she must have taken a red counter on a second go. She couldn't have taken another blue counter because then she'd have a red and a blue. But she hasn't. She's got a red and a red. So it's this branch here and this branch here. So in other words, we just have this probability and this probability happening. So what do we do if they're both happening? We just multiply them, right? So we've got then x over 5x, x over 5x, that's that probability there, okay, multiplied by this probability here. So x minus 1 over 5x minus 1. Okay, and we're told that that probability, so the probability of getting two reds is 6 over 155. So that must be the same as 6 over 155. So essentially all we have to do is just find out x, because remember what x was. X was just the number of red counters which we had in total. So if we find out what x was, then we just get the number of red counters that we had in total, which is what we're after. How many red counters did John put into the box? Okay, so we just need to solve this for x. Well, look at this. Are you happy that we've just got two fractions being multiplied together? So let's think. If we have, for example, 3/5 and we multiply that by 4/7, then what do we do there? Well, we just multiply the numerators together. So we just multiply the numerators together. So this becomes 3 times 4. So 3 times 4. Okay, and then the denominator, we just multiply the denominators together. So just multiply the 5 and the 7 together. So this becomes 5 times 7 on the denominator. Okay. So in other words, when we've got exactly the same situation up here. So all we have to do is just multiply the numerators together and multiply the denominators together. So if we multiply the numerators together, are you happy? We're just going to have x times x minus 1 on the top. So we've got x times x minus 1 on the top. Now be careful, I'm actually going to put this x minus 1 in brackets because I don't want to confuse it with just x times x. I want to make sure I'm timesing x by everything, okay? Then what am I going to have on the denominator? Well, I just multiply the denominators together. So I've got 5x times the 5x minus 1. So 5x minus 1. Okay, and again, same thing, I'm going to put this in brackets to make sure I'm multiplying x by everything. Multiplying by x by the whole 5x minus 1. All right, and that's still equal to 6 over 155. Okay. So can I do any cheeky cancellations just looking at it? Well, yeah, I can. Look at this. I've got an x here and I've got an x here. So I can just cancel those things off. By the way, if this was x plus x minus 1 over 5x plus 5x minus 1, could I cancel? Could I cancel that with that? No, I couldn't. Why? Because I've got a plus here. The only reason why I'm allowed to cancel is because I've got a multiply here. So because I've got a multiply, I can cancel. If I had a plus, I couldn't cancel, okay? But that's just something to be aware of, okay? So I've cancelled those things off, so I've actually got rid of that x there and that x there. Of course, I could have cancelled it there as well, but never mind. I didn't spot it. So let's just look at that then. So let's get rid of that 5 times out the front. Don't really like that. So let's just do 5 times 5x and 5 times negative 1. Okay, so just expand that bracket out. So 5 times 5x, it becomes 25x. Becomes 25x on there, and then 5 times negative 1 becomes negative 5. Okay, so I've just expanded that 5 times 5x minus 1 out. Okay, and again I'm just going to stick that in brackets just so I don't lose it. Now look at this. I've got a fraction and a fraction. Right, now I could cross multiply if you know cross multiplication, but actually, I don't really like looking at fractions. Okay, if you don't know cross multiplication, doesn't matter. So I don't actually like looking at fractions. I think they're fairly ugly. All right, so what I'm going to do is I want to get rid of them. Well, this here means 6 divided by 155. 6 divided by 155. So if I multiply by 155, then I get rid of that thing altogether. So those two things just cancel. But I'm going to have to do the same on the other side as well, aren't I? So I'm going to have to multiply by 155 on this side. So I'll get rid of that. That looks far nicer. I don't like the fractions, so I got rid of that. But I've got 155 times on there. That's okay. That's okay. Well, this is 155 over 1, effectively. Same thing when I'm multiplying fractions together. Just multiply the numerators and multiply the denominators together. So I can just simply stick this 155 on the top. Okay, stick this 155 on the top with the x minus 1. Hopefully there's enough room, which, you know. And then I do the 1 times that. Well, 1 times that is just that. All right. Okay, so again, I don't like the fractions, but I can do exactly the same trick with this. The fact that it's just involving algebra doesn't matter. Okay, I can still use exactly the same maths. It's just I don't know what that value is at the moment. But I will do, I promise you. Okay, so so this is just the same as 155 times x minus 1 divided by 25x minus 5. So in order to get rid of that divided by 25x minus 5, I'm going to have to multiply by the 25x minus 5. Actually, I'm going to stick it over here just to make it a little bit nicer. So 25x minus 5, multiply on both sides, because those things will just cancel. Okay, but I'm also going to have to multiply by the 25x minus 5 on this side as well. So I've got cancellation there. That looks far neater. Again, I've got 6 times there, so just make that a little bit better. So I'm just going to expand this out, and I'm going to end up expanding the left-hand side out as well. So 25 times 6. So 6 times 25 is, well, what's 25 times 4? That's 100. And then I've still got to add on another 2 times 25. So 2 times 25 is 50. So I've got 100 plus 50. That's 150. So I've got 150x there. 150x. Okay, and remember I had 6 times negative 5. Don't forget the 6 times negative 5. 6 times negative 5 is, well, 6 times 5 is 30, so it's going to become negative 30. Okay, similar thing over here. Make sure the 155 times everything through there. So the 155x, and then I have 155 times 1, so that's just going to become 155. Let's make this look a little bit, sort of bring everything together to sort of make it look a little bit tidier. Well, that is just a general linear equation, which I'm used to solving. So if I just, so I'm after x, right? So I want to get all the x's on one side. So first of all, I'm just going to remove this 155 from this side. So I'm going to take it over the equals bridge. and I'm going to put it on this side. But remember, what's the penalty for taking over the equals bridge? I have to change the sign. Okay, so now what is minus 30 plus 155? Well, are you happy that I can just swap it around because I'm just adding? So that's the same as 150 add negative 30, or just 150 take away 30. All right, 150 take away 30. Sorry, 155 take away 30. That is just 125. So that whole thing in there is just 125. That looks a lot nicer. All right. And then if I take this over to the other side, remember that this is secretly a positive. We just don't normally write it, but that's going to make a difference in a minute. Take it over the equals bridge. Take it over the equals bridge, okay, and it becomes then not a positive, but a negative. Have to change the sign. It's the penalty for crossing the equals bridge. So what have I got here? I've got 150 xylophones, and I take away, 155 xylophones, and I take away 150 xylophones. So 155x take away 150x. That leaves me with 5 xylophones. Leaves me with 5 xylophones. So I've got 5 xylophones on this side. Okay, equals 125. So in order to get rid of that, so I've got 5 times x. So I need to divide through by 5. So divide both sides through by 5. They cancel. All right. So what's 125 over 5? Well, simple trick for doing that. So remember, dividing by 5 is nice and easy because I can just convert this 5 into 10 over 2. And then what do I do when I divide through by fractions? I do flip it. Okay, and I change this to a multiply. And this is just over 1, right? So 125 times 2 is 250. And then 1 times 10 is 10. So what's 250 divided by 10? Cancel. That just becomes 25. So this thing here, it just becomes 25. So what's x equal to? 25. Remember what x was equal to. X was the number of red counters that we had, which is what we're asking, what we're being asked. So how many red counters does John put in the box? Well, that's x, and we've just said that x is 25.